Hello?
Hello. Yes.
Hello?
Hello. Is it audible, sir? Can you listen?
Yes.
Yeah. It's good.
Good afternoon. It's Mohammed Shahimi.
Yeah. And nice to meet you. So I think you already visited SRM, right? So
Yeah.
I
I don't
and
I don't know if you see me. Do you
yeah,
see me?
I seen you. So you and your colleagues came on time and gave talk
Okay.
also. And Roberto, sir.
Okay, I'm here.
Yeah. Again, I am. Yes. So I think we have time another 9 minutes, and after that we can start.
Okay.
Yes,
When you give
green
the
signal.
start, we will start. Okay.
So, how are you, sir? So, how is everything?
It's fine.
Fine.
As usual, busy. Okay.
Um,
What about you?
I'm sorry to disturb you in this busy schedule. So, yeah, I'm fine, sir. It's going well.
Okay.
So,
Is there a chance for a travel to the old world in Italy?
yeah, in Italy, but the financial support is the problem, sir. So I will try.
Okay.
Anyway, we are virtually connected and we are publishing together with Colorado, and my students are now coming there. So
You
this
send
year, yeah, this year one
you
more
send
student.
you send the PhD students.
Yeah. So through them, I'm also watching Rome.
Okay.
And time to time, I speak with Gabriele. So if any paper I publish, I share with him and ask him his opinion. So
Well,
it's
now Gabriele got a position, so
yeah. So I think everybody, right? So Alex also now
yeah.
associate professor, and
Yeah, like you.
Gabriele now, like, yeah, me too. So actually, do you want to check your slides, sir? I think you can share your screen and whether
Is it fine?
yeah, it's
Do
fine.
you see?
Yeah, it's fine if you make it full screen. I think it's perfect. Yeah, it's perfect. So you can keep it like
Okay.
this. Yeah, you can keep it like this, and we can know after that we introduce, and after that we can start. Okay.
Yeah. How can I remove the upper menu?
Which one, sir?
There is an upper menu, audio, start, participant, discussion. It's on the top.
Something top. No, I think if you move your if you keep your cursor for some time, it will automatically go. No.
D'accord. Okay.
We are seeing perfect. So we are not seeing any upper menu. No problem.
Okay. Do you see this? Do you see it now?
Yes.
It's okay.
It's okay. It's perfect. No problem. So we can wait for another 6 minutes and we can start.
Great. Okay.
பேனலிஸ்ட் உள்ள ஜூம் போங்களா
Okay, I think we can start actually.
Yes.
Good evening, everyone. I welcome you all for day third last keynote talk. It's keynote talk 18, and for this keynote talk, I'm very happy to introduce our chairperson, uh, Professor Roberto Paolese from Department of Chemical Science and Technologies from University of Rome Tar Vergata, Italy. And SAR's research interests are synthesis and reactivity of metal complex of porphyrins and related macrocycle and thin film deposition of organic materials and development of porphyrin-based chemical sensor and the development of development and application of artificial sensorial system, namely ENOS and ETUNC, and also study of optoelectronic properties of porphyrins and related macrocycle pimples. And for his record, actually, according to Google citation, Google Scholar, he have citation around more than 18,000 and Hutch index of 71 and ICONN index of 309. And with this short introduction, I welcome Professor Roberto Paulese to take over this. Sir.
Thank you, Yuva, for the kind introduction. It is my pleasure to be part again of this ICONN conference, and it is my pleasure to introduce Professor Mohamed Cheimi of the Paris University for the last keynote talk. The title of his talk is New Black Gold from Agro-Wastes. So please, Professor Cheimi, the desk is yours. You have 40 minutes for your presentation.
Thank you very much for the introduction. Do you hear me?
Yep.
Okay, great. Thank you very much, Professor, for the kind introduction. And I would like to thank also the organizer at SRM Institute of Science and Technology for giving me the opportunity to share my results with my young team in Paris on biochar, which is called now in France New Black Gold, because it has there are a lot of opportunities with carbon materials derived from agro-waste for agriculture, for water treatment, and so many other interesting applications. It is also a great pleasure to interact and start a new work with SRM IST, SRM University, after the visit we had of Professor Navanitan Mani recently. He left Paris last Saturday after 2 weeks visit as an invited professor, and it was a good opportunity to share our common interest and start a new and plan to start a new work actually on biochar, hopefully in the coming days. Having said that, I would like to something is wrong with the sorry. Oh, okay. So this topic has emerged from the global awareness of the objectives of the United Nations to reach several goals by 2030 and to banish social ills. Among these goals, we are interested in good health and well-being, especially clean water and sanitation, affordable clean energy, and probably sustainable cities and communities, and could be also Sustainable Development Goals number 9 related to innovation and infrastructure. So concerning water treatment, we are for example, in Paris now we have a lot of trash in the street because of the strike, because of several strikes, but also we can see a lot of pollution in the rivers, and there are a lot of warnings from the environmental scientists in France about the quality of river waters and pollution of sea pollution, and this is this is a global concern. For the treatment of water, there are many interesting materials like metal organic framework, zeolites, clays, which are known for a long time. A lot of work has been done over the 2 last decades on mesoporous silica and their materials. And since the early 2000 years, we a lot of work started on biochar. Biochar is the contraction of biomass and char, and this is the carbon allotrope deriving from the thermochemical conversion of biomass, and now there are a lot of work on the thermochemical conversion of agro-waste in general. Water purification requires a holistic approach. Of course, we can, I have several colleagues who, for example, work on the sensing aspects. You have to determine what is in water, first of all. So you have to have a fast responding sensors. They must be selective with low detection limits. Once you know what is polluting water, you can have different approaches like adsorption to remove the pollutants, but adsorption, you end up with unadsorbed pollutants, and the idea is to go to complete mineralization of the pollutants, especially when they are organic compounds. Of course, for metal ions, it is a completely different situation, because you cannot mineralize they are already minerals, and unless you have to transform them into metals and collect them. But for organics, the complete mineralization could be the interesting approach towards the water purification. We worked on a few examples like of dyes, like malachite green, which has some adverse effects. It is used in the industry for example, for canned peas. It is used also in fish farming, but it has side effects like skin discoloration, and similarly methylene blue can have adverse effect like jaundice and nausea. So we have developed new materials based on biochar to test our materials and see how they behave in the degradation and complete mineralization, if possible, of these model pollutant molecules. So the objectives is to design new biochar materials and valorize the agro-waste into useful materials for the water treatment and other applications. And we have selected the slow pyrolysis for this thermochemical transformation, conversion of agro-waste into biochar. We worked on the parameters influencing biochar features, and I would like to show a few examples of application of these biochar nanocatalysts designed by impregnation of the biomass followed by pyrolysis. So as I said, the applications concern degradation of dyes and electrocatalyzed reduction of nitrates. And I will finish by a new applications, but perhaps the first ever application of biochar in the treatment of neglected tropical diseases. This concerns tropical countries like, for example, South India. And I will come to the conclusion and perspectives. For the our work falls into the concept of waste to wealth. So we transform any waste into something useful and with a high added value. The principal objective is the valorization of agro-waste into functional biochar. This could be obtained biochar from agriculture, from field scale crops, fruit trees, animal farming, or from the industry. For example, we have samples from the industry, like from the juice industry or processed food, and also from, it could be from paper or essential oils. From the food industry, for example, we have artichoke. We are working now on artichoke waste provided by the food industry, the canned artichoke. The agro waste, of course, can be treated in the compost or exploited to provide biodiesel, give sorry, I have a okay, obtain biogas from the agro waste, or this is our racehorse is the work on biochar. Sorry, it seems something is wrong. Sorry, with my with the.
Actually, we can see your screen. It's okay.
Yeah, but oh, yeah. Sometimes I cannot change it. Yeah, so the lignocellulosic biomass structure is the following. We at the inner parts we have the fiber of the cellulose, and the fiber of cellulose are coated by hemicellulose, and all together they are glued by lignin. So there are some Chinese groups who work very actively on the mechanism of carbonization and the transformation of these molecules and polymers into sp2 carbon materials. This is outside the scope of our work, although we started to think about using the TGA, thermal gravimetric analysis, coupled to infrared and mass spectrometry to study our agro waste and see how they get carbonized during the pyrolysis process. So we simulate the pyrolysis conditions into with the TGA setup. But for the moment, it's in progress, and I will not mention this. These are some of the crops on which we have worked: olives, sugarcane, pomegranate, and barley and hop for the production of beer. And we have been provided some brewer spent grain from a local company in Normandy who produces organic beer. And these are, for example, the pomegranate peels. We have sugarcane bagasse, but we scratched the sugarcane bagasse to get the pulp bagasse, and also the olive pit after the production of oil. We have adopted usually in the literature, when we want to produce biochar with a loaded nanocatalyst, usually biochar is formed and then modified with metal ions, which are reduced on the top of the biochar. In our case, we have used a completely different and more straightforward approach. We start with the biomass. We prepare the metal ion solution, like for example here, copper and nickel nitrates. We impregnate. It's called the wet impregnation method, and we pyrolyze the biomass powder with impregnated metal ion salts. We can have, for example, copper, nickel, silver. We can have a combination like copper, nickel, or silver, copper. And of course, the combinations are, you can have a large series of metal ions that you can load on the biomass and before pyrolysis. Anyway, we have selected the least expensive ones like copper and nickel salts. Okay, we have also silver nitrates, but we also work on zinc acetate to provide zinc oxide, because we are also interested in photocatalyst like zinc oxide. Pyrolysis parameters are very simple. For example, for the mass loading, we use the usually the generic concentration is 1 millimole of salt per gram per 1 gram of biomass. We work under nitrogen. Sometimes we use hydrogen to boost the reduction of the metal ions. Usually we work at 400 to 500 degrees, but sometimes from 300 to 900 degrees to check the temperature effect. Usually we work at between 10 and 30 degrees per minute ramp for the increase of the temperature in the tubular furnace. Okay, so this is how it looks like. We start with the, for example, with the powder. It changes color upon the impregnation depending on the mixture we have here, and but the final material is black wherever, whether it is pure biochar or it is biochar with loaded nanocatalyst. Of course, we have a lot of techniques. The problem of biochar fundamental science is that you work with agro-waste, with trash, and trash is it costs nothing, but the characterization requires a lot of techniques like XPS, Raman spectroscopy, TGA, SEM, and EDX. If you have, for example, supported nanocatalysts, the reviewers request high resolution TEM, so it is quite costly. And also, if you work on the control and the porosity of the biochar particles, and also the effect of the immobilized nanocatalyst, you also need BET surface area measurements, among others. Once you publish your work with, you submit your work with 5-6 analytical techniques, reviewers have always the idea to ask you for another technique which they believe is important for the study. So it costs nothing in terms of chemicals, but it is very costly in terms of characterization. Something is wrong with my
No, but it's the slide is not moving, sir.
yeah, I don't know.
Maybe stop sharing and again sharing.
Oh, okay,
yeah,
okay.
It's okay now.
Okay, so for example, this is with olive pit particles from biochar. It looks like a melted wax, not very porous. You can see some pores here, but you can see the nice distribution of copper nickel. We can of course monitor the surface elemental composition by EDX. We can see here the impregnation of the metal of the biomass with metal salts. We can see copper and nickel, and when you have here the after pyrolysis, there is less oxygen, of course, more carbon and more copper nickel. And because of nickel, these biochar materials are magnetic and attracted by magnets, so we can collect them after any catalyzed reactions. Of course, if you load up to, for example, 10 times more copper than nickel, the final material biochar with copper nickel is not attracted anymore by a magnet. For example, by XRD, we show that the nickel or copper are in the metallic state, with the existence of some oxides at the surface of the nanoparticles, and the graphitization degree of the biochar is monitored by Raman spectroscopy. We determine the D to G peak ratio, and usually we check whether the G band has an increased intensity, height, or peak area, dependent on the condition of the pyrolysis. And of course, TGA permits to monitor the loading of the nanocatalyst on the biochar. This was our first application. It was really at the beginning of our program in early 2021. 1 year and almost 2 years ago now. We started with something very simple, the degradation of methyl orange, but it was a reductive process. So actually, you can see that with the copper nickel, the molecule is split in two, but you can see that you start with one organic molecule and end up with two. So that was our first application to test the concept, and we soon moved to the mineralization of the organic compounds. So we moved to the advanced oxidation process using the copper nickel or other nanocatalyst, metallic or bimetallic nanocatalyst on biochar. This is with sugarcane bagasse, for example. The pulp of sugarcane, the pulp of the sugarcane, it gives very interesting biochar materials, as I will show later.
Hello, I think you're muted. Sir, kindly unmute yourself.
Hello?
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 Yeah.
Hello?
Yeah,
Now it's okay.
now it's
Yeah, okay. So, yeah. Okay, so what we see here is that, for example, with the what we have tried in the IOP process is to get rid of all organic molecules. Of course, we need additional experiments like HPLC or mass spectrometry or total organic carbon experiments to determine if all organics have been removed, completely transformed into carbon dioxide, water, and dinitrogen, if it is the molecules in the beginning, the initial molecule contains nitrogen. We worked, of course, on single dye solution, but soon we tested the mixture of dyes and see how they behave vis-a-vis the catalyzed reactions. So this work is now under revision for publication in environmental research, but you can see we try to control the kinetics of the reaction, the degradation reaction. We expected probably more activity with 4 times loading of copper nickel, but actually we found that the lowest loading of nickel here provides the fastest degradation of the dyes, and this is because at high loading the nano catalyst is agglomerated and the activity is reduced because we have less access to the catalytic sites. This is another example on sugarcane bagasse with silver and copper. We have gone through advanced oxidation process, and we were asked if about the fate of the nanocatalyst, and of course we have by NMR we have determined that there was at the limit of detection of the technique that there was no organics left in the solution, in this colorless solution, but also by XRF, by X-ray fluorescence, we have checked that there was no nanocatalyst dispersed in the solution, which means that the nanocatalyst is tightly bound to the biochar. We have gone also with some collaborators to electrocatalyzed reaction. This is their work with microelectrodes, and we have microcavity electrodes. We have prepared copper nickel on biochar powders for the catalyzed electroreduction of nitrates into NH3 or N2 by electrochemistry. This, however, in this work, we had to go up to 900 degrees to have a very graphitized material, because biochar prepared at 400 or 500 degrees is not yet sufficiently conductive to be used in electrochemistry and permits the electron transfer. So this work is under progress and will be submitted to an electrochemistry journal. This is a collaborative work with some colleagues from Southeast Paris. Okay, I mentioned about the applications, the need for in catalysis for high surface area. Usually, high surface area biochar is prepared using treatment of the biomass by KOH or by phosphoric acid. We abandoned these routes and we preferred, for example, to work on maceration, mechanical grinding, and also use the precursor of the immobilized nanocatalyst to provide a very porous structure. You can see here what I have shown earlier, the olive pit, but the olive pit does not provide a lot of porosity, but you can see with the same protocol applied to sugarcane bagasse, the pulp of sugarcane, you can see that we have here a porosity, a structure like a fishnet structure that is induced by nickel. If you check with if it works for copper nickel, if it works with copper, it does not work. Only nickel provides this fishnet structure of the biochar during pyrolysis, and this has been well documented in the literature. We know now from a Chinese group that nickel, they explained the mechanism of creation of porous structure using nickel precursor to obtain immobilized nickel nanocatalyst. We can also use the maceration if we, for example, we warm up the we heat we treat the biomass at 80 degrees in water alcohol mixture. You can see here that the extracted, we extract some polyphenol, some natural extracts which could be used as phytochemicals for the do you hear me? Hello?
Yes.
Oh, okay. So you can see after extraction, after maceration, we start to have some dots, some holes here, and these are these holes initiate the formation of porous structure of biochar. And we have, for example, from the biochar and biochar after maceration, we have obtained an increase in the surface area from about 270 meters square per gram up to 350 or 360 meters square per gram. Okay, it's not 1,000 or 2,000 meters square per gram as claimed by some groups when they treat with KOH or with phosphoric acid, but at least we have a green way to obtain here some porous structure. And finally, you can see this is a brewer spent grain using mortar and pestle and mortar, and we can have a porous structure that we cannot obtain with if we, for example, we use a coffee mill or a blender. We tried with a blender from a local shop, and so mechanochemistry should provide not only porous structure but also some graphitization of the biochar. So this is another green way to obtain a porous structure of the biochar. So by mechanical grinding of the initial biomass. Okay, so we have, of course, studied the brewer spent grain with immobilized catalyst in the degradation mineralization of dyes. And also another application of the because my time is I'm running out of time. So here, for example, we loaded silver from silver nitrate obtained by pyrolysis of olive pit powder particles loaded with silver nitrate. We obtained biochar with immobilized silver nanoparticles, and we have employed these nanoparticles in the treatment of leishmaniasis. This is dermatological nasty disease. It is ranked as a neglected tropical disease, and we have done a lot of work with Laguna University, a center of parasitology, and we found that our materials are they fight these microbes, these parasites without any significant cytotoxicity. So the importance is, of course, is to treat the disease, but not to affect to have medical side effects. We have done this with silver. We have done also this with a bimetallic material like silver and copper, and we check that the parasites they change, the shape of the parasites change after interaction with the biochar with immobilized nanoparticles. For example, we have tried the combination of silver and copper. Both are antimicrobial materials. And we found actually that both work very well, but we noted less cytotoxicity in the case of pure silver. So this work will continue with Laguna University in the Canary Islands. So to conclude, we have developed diverse methods for making nanocomposite nanocatalysts. Our biochar nanocatalysts were designed for dye and nitrate removal by this second application by electrochemistry. Copper nickel or pure nickel provide magnetic biochar, which can be collected, recovered simply with a magnet. We try to understand how the textural properties are changing from one biomass to another, or depending on the pyrolysis conditions. As a valorization of these agro-waste into biochar, we hope to continue to address the United Nations Sustainable Development Goals, like most of the work is done to address clean and water sanitation goals, but also we work on SDG 3 for the treatment of neglected tropical disease. And from the literature, from also in France, for example, Net Zero Company, they in the newspapers, for example, in magazines, they advert their work and their applications of biochar and call it the new black gold for agriculture and many other timely applications intended for the sustainable developments. So as perspective to this work on the fundamentals science viewpoint, we would like to, as I said, to work more on the, because we work on different agro-waste, but we would like to correlate, have a better understanding of the pore structure, how it is created, and how it relates to the biomass nature and composition. Of course, we are interested now in the pyrolysis parameters effect, and we are submitting a new paper on this aspect probably today or tomorrow in a Journal of Applied Pyrolysis. We would like to understand also the nature and loading of the precursor. As I have shown earlier, we see that nickel imparts some significant porosity to the biomass. And also we have a new work starting on the combined method. For example, hydrothermal treatment of the biomass, followed by that is in, for example, of course in water at high pressure, but followed by pyrolysis up to 500 degrees. We work on the wet and impregnation. For example, I can show you here a new work we are about to submit. You can see in the same conditions how we can obtain zinc oxide nanoparticles on different biochar, and it has completely different structure depending on the biomass nature and its composition. For example, here on marine algae, here on mandarin peel biochar, and here on sugarcane bagasse. So we are trying to understand how these structures are created of Z and O, and in relation to the exact composition of the initial biomass. Next is probably, of course, a lot of groups work on pollutants like dyes, but I think the emerging pollutants are what are called eternal pollutants, like polyfluoroalkyl substances, and of course continue our work on NTG. For the perspective from the technological development, there are a lot of opportunities for academics, like creation of new SMEs. For example, Net Zero in France was created by academics. Exploit local agro-waste to minimize the transport, use of fuel, create a new functional biochar with controlled properties for sustainable development, like energy production, gas reforming, water depollution, biomedical application, and not only agriculture, as it is up to now for the applications of biochar. For example, we are working with Qatar University on the development of new biochar with loaded nanocatalyst for the reforming of CO2 into CH4. This work has just started in a new international bilateral project with Qatar University, and we started to have some interesting results on the biochar nanocatalyst we have designed. I would like to thank very much my young collaborators in Paris, Youssef, Mengshi, Arvind from Namur, but he's Indian from Bihar, Saint Joseph College. Ermin, she was a second-year student last year, and also he published his work. Ermin will publish her work soon, and my collaborators from Canary Island, from Egypt, Mohamed El Garah from Troyes for all the characterization he is doing. Our provider of brewer spent grain in Normandy region, my colleague Dr. Bakr from Qatar University, my former student, she's a brilliant now researcher in Qatar University, Khulud, and Ahmed Gamal. He is developing with us the CO2 reforming. I would like to thank our sponsors, and I would like to thank you very much for your kind attention. Thank you.
Thank you so much for Professor Shemi for this interesting talk. So the discussion is open, so if there are questions. Okay, I have a curiosity question, because you talk about the zinc oxide supported
Yes.
on bio. Do you have an idea if there is some, because zinc oxide is photoactive, if biochar can interact, disturb the photoactivity of zinc oxide, since because it's a black powder, if there are some interaction or not?
You mean interaction, molecular interaction for the immobilization of zinc oxide, or you think, or you mean inhibition, reducing the activity of?
Yeah.
Well, no. We have actually found that the degradation of, for example, some dyes like malachite green, it occurs within in less than 10 minutes, and if we do not put the zinc oxide on the, we do not pyrolyze the biomass impregnated with the zinc acetate, it does not work. So the zinc oxide is there, and it is really important to be there on the biochar for the to obtain a catalyzed reaction, a true catalysis phenomena. So it is really important, and I don't think your question is really accurate, and probably we should think about it and see how the light could be absorbed, of course, because the black color of the biochar. But so far we didn't see any inhibition of the biochar.
Okay, thank you. Other questions?
I'm Yuvraj, and actually we also work in zinc oxide, and so I have one doubt. So I think zinc oxide, you said it's extracted from bio waste, agro waste, and
no,
it is not.
We use zinc acetate as a precursor. Okay. We mix the zinc acetate in wet impregnation, because we tried earlier mixing the powders, the powder of the biomass and powder of that is the dry impregnation. It does not work. It does not give a good catalyst. But when we start from the zinc acetate, we impregnate the biomass with an aqueous solution of zinc acetate. It works remarkably well, and we obtain, of course, the zinc oxide nanoparticles on biochar.
On a biochar.
Yeah, but I have one comment to return to your question. For example, now, for example, those groups who work on sludge, for example, wastewater sludge. Wastewater sludge has a lot of rubbish, sometimes a lot of metal ions in the wastewater, and there is no need of impregnation at all. So some groups, they work on the sludge, and they pyrolyze the slides directly to have a catalytic biochar material. So this is something very interesting, and we have envisaged work in this direction with on samples provided by Aquagreen in Denmark. So this is interesting to avoid, for example, in the future, any use of chemicals we have to buy from Aldrich or from another supplier. Thank you for the question.
Okay, I got it.
Other questions? No, if not, let's thank again the speaker for me for the talk. So we close this last session for the ICONN, and Yuva, please go ahead.
Okay, so thank you, Roberto sir, for your valuable time, and so on behalf of organizing committee, I thank you once again for this sharing this. Thank you so much. So now time for awards and the concluding session. All participants, kindly stay, and that awards ceremony will start.
A very warm good evening, galaxy of intellectuals, invited guests, professors, students, and ladies and gentlemen. On behalf of the organizing committee, I am delighted to offer a gracious welcome to the valedictory ceremony of ICONN 2023. It's my pleasure to invite Dr. C. Preferential Kala, Associate Professor, Department of Physics and Nanotechnology, to welcome the gathering. Kindly, ma'am.
Very good evening. It is immense pleasure and privilege for me to deliver the welcome address for the valedictory function of ICONN 2023. At the outset, it's my pride to welcome Professor Mohamed Chahimi, University of Paris, France, for delivering the valedictory address. We are very thankful to you, sir, for being with us and sharing your valuable thoughts in ICONN 2023. I would like to welcome our Honorable Registrar, Professor Ponnusamy, for accepting to deliver the concluding remark and the award distribution of ICONN 2023. I also extend my welcome to Mr. Vinod Kumar, Senior Manager, Springer Nature. Finally, I welcome the convener, ICONN 2023, Professor John Thiruvadigal, HOD, Professor Karthikeyan, Department of Physics and Nanotechnology, SRM Institute of Science and Technology, and the delegate participants, my fellow colleagues, and the students for this valedictory function. Welcome you all. Thank you.
Thank you, ma'am. Now let's have a subsequent conference report that provides an overview of the various sessions as well as insights and discussions which was transcribed during the conference. I now request Dr. R. Annie Sujata, Associate Professor, Department of Physics and Nanotechnology, to give the report about the conference. Kindly, ma'am.
Good evening, everyone. I am pleased to present the report of ICONN 2023 conference. The 7th International Conference on Nanoscience and Nanotechnology, ICONN 2023, commenced on 27th March 2023 at 9 a.m. in the Indian Standard Time. Professor Chennupatti Jagadish, President, Australian Academy of Sciences, Australian National University, inaugurated the conference with a thought-provoking address. Our Honorable Vice Chancellor delivered the presidential address. Professor Kazuyuki Hisum, President, Shizuoka University, offered the felicitations. The 7th edition of ICONN 2023 was structured with diverse themes: low-dimensional materials, 2D materials, surfaces, interfaces and thin films, nanocomposites and nanocatalysts, multifunctional nanomaterials, molecular and nanoelectronics, nanosensors and nanoactuators, nanomagnetism and spintronics, nanotribology, manipulation, characterization of materials and nanoscale, industrial nanotechnology, products and commercialization, quantum information processing, thermodynamics at nanoscale, green nanotechnology and water treatment, photonic and plasmonic nanomaterials, metamaterials and metasurfaces. ICONN 2023 was a technical feast with 49 parallel sessions, 9 keynote sessions, 18 keynote lectures, 2 theme lectures, 76 invited lectures, 194 contributory lectures, 1,621 poster presentations delivered by world-renowned scientists and researchers across all parts of the world. The different sessions provided the framework of a great research in diverse fields. On the day 2, as part of ICONN 2023, we organized Seeding Nanoscience in Young Minds, live interaction with nanoscientists, an exclusive program for the bright young students of age group between 14 to 19 from India's top intermediate and tertiary colleges, aimed at creating awareness on nanoscience and nanotechnology and its applications. Professor K.S. Rangappa, former General President of Indian Science Congress Association, has delivered the presidential address, and an eminent scientist, Professor Chennupati Jagadish AC, inaugurated the event and interacted with students. To motivate and honor the researchers, ICONN has also constituted expert panels and also presents awards under different categories. SRM ICONN Innovation Award, SRM ICONN Outstanding Women Researcher Award, SRM ICONN Young Researcher Award, SRM ICONN Best Oral and Poster Award, with special categories in the Poster Award, Kawazoe Best Poster Award, Springer Nature Best Poster Award. The conference has provided an excellent platform to explore recent advancements and innovative ideas and challenges in nanoscience and nanotechnology. The participation of a rich research fraternity, an impressive lineup of scholars from across the globe, the support of our collaborators, sponsors, and media partners, an array of carefully selected, well-researched and well-presented papers on various themes, a conglomeration of all these to admirably make this ICONN 2023 conference a huge endeavor, assuring us with a pack of great knowledge takeaways to each one of us. Thank you.
Thank you, ma'am. It is a great privilege to have Professor Mohamed Chehmi, University of Paris, France, with us today. Professor Mohamed Chehmi obtained a PhD in Physical Organic Chemistry at Université de Paris. He is currently a research director at the National Center for Scientific Research, CNRS, France. He is an expert in surface modification and XPS surface analysis. Professor has supervised over 25 PhD theses and collaborated with researchers from 20 countries. With over 330 research papers, 25 book chapters, and 3 patents to his credit, he is also the editor of 4 books and has guest edited 6 themed issues. As executive EIC of Chemistry Africa, he recently signed on behalf of the Tunisian Chemical Society an agreement contributing to the achievement of the 17 Sustainable Development Goals of the United Nations. With this brief introduction, I request Professor Mohamed Chehmi to deliver the valedictory address. Kindly, sir.
Thank you very much. Do you hear me? Thank you very much. It is my pleasure to participate to ICONN 2023. This is the first time, actually. I gave a seminar a while ago before the COVID in 2017, and we with the help of Professor Mohamed Jouini, my colleague from University of Paris Cité, we have this collaboration continued with SRM, and recently we had the great pleasure to have with us Professor Navanitan Mani from SRM to join us, share his ideas, and start and pave the way for a new development with SRM. So it is this ICONN conference could be as the 0.0 of the start of a new collaboration and a new era with in this bilateral work, joint work between University Paris Cité and SRM, and hopefully I will meet you all in SRM in person shortly in the next months to interact with you live and start something new and interesting together within the sustainable development with the sustainable development aspect. So I'm pleased, very pleased again to have interacted with you today, and hopefully we will share more knowledge together and disseminate our joint knowledge in the domain of materials and for devices and for the to meet the goals, the sustainable development goals relevant to water treatment, energy, and innovation. Thank you again for inviting me. It was a great pleasure interacting with you. Thank you very much, and I hope to see you in person soon in Chennai. Thank you very much.
Thank you, sir. Experiences vary, which is why after any event, it is important to collect the feedback. We value feedbacks, which helps us to develop, facilitate, self-reflect, and motivates us to narrow the gap and improve further. Due to short of time, any three participants can share their views by raising your hand.
Good evening, one and all. I would like to thank SRM, the ICONN organizers, and all the faculty members, volunteers who helped us to make, give us presentations and make a platform, create a platform for us for collaboration. And even though it was virtual, we had a lot of speakers from various domains, and it was really helpful, and it was very cherishing for us to broaden our knowledge in the domain of our own research and get to know more about other fields, what the research is currently going on. Thank you. This is Karthik from Anna University, Chennai.
Yeah.
Hello.
Hey.
Good evening, everyone. This is Shweta here. I'm a PhD student at IIT Bombay Monash Research Academy. So firstly, I would like to thank the entire committee of ICONN for organizing this amazing conference. So everything was organized very well. Even though it was in a virtual mode, everything went very smooth and there were no glitches at all. But still, I would like to attend the conference next time in person. So I would like to make a request that if this huge conference could have been in person, it would have been it would have offered much more opportunities for us to connect with the fellow researchers. So yeah, I would like just one request that if it could be organized next time in person, that would be really great. Thank you once again.
Yeah. Mohammed Jouini, can I give it just a few words? Hello?
Yes, sir. Please, please. You can.
Yeah. Okay. Thank you very much. Mohammed Jouini from Université Paris Cité. I'm the colleague of Mehdi who he told about me. I would like to first thank all the organizers, and particularly Dr. Kartijayan for his kind invitation and to participate in this 7th ICONN 2023 conference. Which was a good conference with a good level, high level, scientific level. I would like to thank you again and thank all the participants and all the organizers for their kind and real help. And I hope all the success for all your next conferences, ICONN conferences. Thank you very much again. Thank you. And I hope we can go further in our collaboration with your institution. Thank you.
Thank you.
Thank you, so for your valuable feedback and suggestion. That was really worth mentioning. An award is not only a great prestige or a mark of excellence, but is also a tremendous boost for someone to strive and excel higher. I now request Dr. N. Angeline Littleflower, Assistant Professor, Department of Physics and Nanotechnology, to announce the Best Oral and Poster Awards of ICONN 2023.
I'm delighted to announce the Best Oral and the Poster Presentation Awards of ICONN 2023. The Best Oral Presentation awardees are Shwetarani from IIT Bombay, Monash Research Academy, Mumbai, CL 188, Baliram Srirang Nadekar, VIT Vellur, CL 123, Miriam Daniel, Department of Chemistry, SRM IST, CL 41, Ramya Niyogi, CSIR, Central Mechanical Engineering Research Institute, Durgapur, CL 178, Gina George from SRM IST, CL 174, Archana Tiwari from Department of Physics, Institute of Science, Banaras Hindu University, CL 39, Anvesha Mukherjee from Tel Aviv University, Israel, CL 177, Joy Mukherjee, NAG Laboratory Institute of Physics, Sachvalaya Mark, Bhuvaneshwar, CL 164, Chellayan Selvakumar, University of Shugba, Japan, CL 40, John Donald Raj, Department of Physics and Nanotechnology, SRM, CL 187. The Best Poster Presentation awardees are Karthik from University of Madras with the CP number 760, Vijendra Kumar, IIT Kharagpur, CP 1022, K. Annamalai, University of Madras, CP 1252, Jyotirmay Roy, Pondicherry University, CP 1455, Rishad Baig, CSIR NIST, CP 1543, Mansi from CSIR CSIO, CP 1453, Ardra Darshan from CSIR Central Electrochemical Research Institute, CP 1502, Soundarya Mary, CSIR Central Electrochemical Research Institute, CP 1544, Parvati from University of Calicut, CP 1548, Jagadish of SRM IST, CP 1554, Banu Chetri from Northeastern Hill University, CP 1550, Arpita Mukherjee, SRM Institute of Science and Technology, CP 255, Bhaskaran from SRM IST, CP 1197, Hisna from University of Calicut, CP 1549, Pradnya Bapte, SN Arts, DJM Commerce, BNS Science College, CP 87, M. Irfana Amran, Shadakatullah Appa College, CP 88, Aishwarya M. from IITDM Kanjipuram, CP 301, Anand Shukla from IIT Patna, CP 312, Sunidhi Sharma from Tapar Institute of Engineering and Technology, CP 454, Avijit Patra, Indian Association for the Cultivation of Science, CP 478, Shefali Jaiswal from IIT Dhanbad, CP 480, Mane Vijay Arjun from Dr. Babasaheb Ambedkar Markwada University, CP 508, Saurav Mishra from KIT University, CP 512, Pratik Kumar Lakhani, the Maharaja Sayajrao University of Baroda, CP 522, and Dharmalingam SRM Institute of Science and Technology, CP 708. Next, I would like to announce Professor Cavozo Poster Prize awardees for the best poster in ACCMS Symposium on Computation Materials, Methods, and Numerical Techniques. Ratnamala Narsingh Rao from Parul University, Gujarat, CP 47, Kannan from SRM IST, CP 58, Christina Lefteria Zilov from National and Cambodstrian University of Athens, CP 54. Now I request Mr. Vinod Kumar Sugumar, Senior Manager, Springer Nature India Private Limited, to announce the Springer Nature Poster Prize for doctoral students.
Yeah, good evening, everyone. Thank you very much for inviting us, and it is our pleasure to be a part of ICONN 2023 conference. And I'm pleased to announce here the Springer Nature Best Poster Prize for the doctoral students category. The first one is Yuvasri Jayavelu from National Institute of Technology, Warangal, CP 525, in the area of application of photocatalytic dye degradation of W-doped nanoparticles. And the second one is Vidya S. Menon from SRM Institute of Science and Technology, CP 1521, in critical role of doping on energy level alignment of Neox hole transport layer based solar cell. And Ravil Zirov from Nikolov Institute of Inorganic Chemistry, CP 41, MD study of CO2 hydrates formation in dependence on H2O CO2 system composition. And the last one is Kyuti Nguyen from Jeonbuk National University, South Korea, CB 534, nanoplates like bismuth oxide electrodes for high performance oxygen evolution reaction application. Thank you everyone.
Thank you, sir. The participants can download their oral and poster certificates through their ICONN login from April 5th, 2023, and the portal will be open for 1 week to download the certificates. I repeat, the participants can download the oral and the poster certificates through their ICONN login from April 5th, 2023, and the portal will be open for 1 week to download their certificates. Congratulations, awardees. Now, I kindly request our beloved registrar, Professor S. Ponnasamy sir, to announce the SRM ICONN Special Awards and to give the concluding remarks of ICONN 2023. Kindly, sir.
Yeah, thank you. Distinguished speakers, Dr. John Thiruvadigal, Dean Sciences, and other colleagues, participants, research scholars across the globe, a very good evening to all of you. It is a great pleasure for me to announce the awardees of ICONN 2023. The first award is SRM ICONN 2023 Innovation Award. Congratulations to all the winners. This award goes to Dr. Iswaraya Varia, Research Assistant Professor, Department of Physics and Nanotechnology, SRM Institute of Science and Technology, Katangalattur, India. So let us congratulate, and his research interest are 2D layered materials, sustainable manufacturing, polymer nanocomposites, sensors, and flexible electronics, energy generation and conversion. The H-index, citation, US patent, and startups are given in the certificate. So congratulations to him. Congratulations to Iswaraya. So then the next award is SRM ICONN 2023 Outstanding Woman Researcher Award. This goes to Dr. P. Sujata Devi, Chief Scientist, Chemical Sciences and Technology Division, CSIR, National Institute of Interdisciplinary Science and Technology, Thiruvananthapuram. Her research interests are advanced functional materials, dye-sensitized solar cells, ion-conducting oxides, nanomaterials for sensing. Her H-index is 36. She is having total number of 141 publications in her area of interest. The third one is SRM ICONN 2023 Young Researcher Award. It goes to 3 persons. The first one is Dr. J. Archana, Research Associate Professor, Department of Physics and Nanotechnology, SRM Institute of Science and Technology, Katangalattur, Chennai, India. Her research interests are semiconducting nanostructures, dye-sensitized solar cells, perovskite solar cells, nanostructured thermoelectric materials. The total number of publications are 133 and H-index is 26. The second Young Researcher Award goes to Dr. K. Karthikeyan, Associate Professor, Department of Physics, School of Advanced Sciences, Vellore Institute of Technology, Vellore. His research interests are two-dimensional nanostructures, high-performance supercapacitors, self-charging power cell system, electrochemical field effect transistors, electrochemical water splitting, biomedical nanotechnology. Total number of publications 126 and H index is 56. So the third one goes to Dr. Swaroop Roy, Assistant Professor, School of Bioengineering and Food Technology, Shulani University, Himachal Pradesh. His research interest are bio-nanocomposite, biopolymers, nanomaterial, food packaging. The H index is 35 and the total number of publications are 113. Congratulations to all the prize winners and awardees. So thank you very much for giving this opportunity. Let us go to the concluding remarks now. It is my immense pleasure to be the part of this successful event, 7th International Conference on Nanoscience and Nanotechnology, ICONN 2023. First of all, my sincere thanks to Professor Muhammad Shehimi, University of Paris, France, for joining this evening with us. As everyone aware, nanotechnology has become the subject of modern science and forefront of technologies in the present and future. It has great importance in improving products, treating diseases, and serving humanity in all areas of life. Nanoscience provides great hope for future scientific revolutions in physics, chemistry, biology, engineering, and others. In fact, in this international conference, we spent 3 days altogether thinking to advance the science and technology for contributing to the research community. We have come across the excellent keynote lectures covering various fields such as multifunctional nanomaterials, nanocatalyst, nanoelectronics, nanosensors, nanostructured thermoelectric, and solar cell materials. The conference went pretty smoothly, considering it all started in the year of 2010, and now the conference has become an important event in the calendar for the scientists, academicians, researchers, industrialists, and students to showcase their latest and significant research finding. We are grateful to Shizuoka University, Japan, to join the hand with us right from the beginning, and other partner association universities. Now we have come to an end of the conference that features an enormous number of contributions that shed light on the mind of young researchers, students, which is a true success of this event. Finally, I would like to congratulate Professor John Thiruvadigal, Dean Sciences, and his team, all the faculty members of the Department of Physics and Nanotechnology for making this event a grand success. My best wishes to all the participants. Thank you. Thank you for this opportunity.
Thank you.
On behalf of the organizing committee, I express my heartfelt congratulations and wishes to the awardees. I thank our Honorable Registrar Sir for announcing the awards and for the concluding remarks of ICON 2023. Thank you, sir. Gratitude is the most expressive form of courtesy. It's time to acknowledge the contributions, hard work, and the presence of you all for this great event. As we come to the close of our valedictory ceremony of ICON 2023, I invite Professor Muller, Department of Physics and Nanotechnology, to deliver the vote of thanks.
Good evening, all. I'm very delighted to express the vote of thanks here on behalf of the organizers. We offer our deep gratitude to all those who have contributed to the grand success of ICON 2023, an enlightening and enjoyable event. We thank Professor Mohamed Chemhi, University of Paris, France, for his valedictory address. We sincerely thank our registrar, Professor S. Ponnuswamy, for gracing this occasion, announcing the prize winners and presenting the concluding remarks with his kind, encouraging words. We also thank Mr. Vinod Kumar from Springer Nature for his kind presence. We sincerely thank Defense Research and Development Organization, Government of India, Council of Scientific and Industrial Research, CSIR, Government of India, Indian Science Congress Association, and Springer Nature for co-sponsoring ICON 2023. We profoundly thank Shizuoka University, Japan, NYCU, Taiwan, GNS Science, New Zealand, University of Rome, Tar, Vergate, Italy, Indian Ceramic Society, the Asian Consortium on Computational Material Science, Innovation, Science and Technology Foundation, Tirupati, Indian Physics Association, and Solar Energy Society of India for being associated with ICON 2023 with their kind wishes. We thank all the internationally eminent invitees who were present in the inaugural function and in the special session, Seeding Nanoscience in Young Minds, live interaction with nanoscientists, conducted in association with Indian Science Congress on the second day of ICON 2023. Thanks to all the renowned keynote speakers, invited speakers, participants who made oral and poster presentations for your detailed deliberations during these 3 days. Now we are very grateful to our beloved chief patrons, our beloved founder chancellor, Dr. T.R. Parivendar, Dr. Ravi Pachamuthu, Pro-Chancellor Administration, Dr. P. Satyanarayanan, Pro-Chancellor Academics, and Dr. Shivakumar, Chairman Ramapuram and Tiruchi campuses for their kind support. We are very thankful to the constant guidance and support, suggestions from Professor C. Muttamal Chelvan, Vice Chancellor, Professor S. Ponnuswamy, Registrar, Professor T.V. Gopal, Dean, College of Engineering and Technology, Professor B. Napoleon, Dean Research, Professor John Tiruvadigal, Dean Sciences, and Professor Karthikeyan, HOD, Department of Physics and Nanotechnology. Thanks to the support extended by various wings of SRM IST and their teams, Director International Relations, Associate Director Campus Life, Maintenance, Director Communications and Media, and Director ITKM, and all those who have helped us in the smooth conduct of this event. Many thanks to all the dear colleagues and students of Department of Physics and Nanotechnology, SRM IST, for bringing the event to this virtual stage, and all the participants of ICON 2023. Once again, I thank everyone. Thank you all.
Thank you, ma'am. I request one and all to raise for the national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
It was a spectacular experience having you all in this great spectrum of ICONN 2023. We are eagerly looking forward to meet you all in our vibrant campus in the 8th edition of ICONN in 2025. Thank you all. Have a great day.
Thank you all. Thank you.
Thank you very much. Thank you, Professor MD. Thank you.